Hi everybody, it's Professor Stevens. I'm going to work on this problem with you and some problems that are similar, looking at the skills that are involved for this type of problem from different perspectives. And so the first one, we'll just read the directions together. It says the function defined by f of x equals x to the fourth power plus 2x cubed minus 32x squared minus 96x has the graph as shown. Use the graph to factor the polynomial. Now we can do this because we know that wherever the graph touches or crosses the x-axis, those would be zeros of the function. And it appears by looking at this that the graph touches right here, here it crosses, and here it crosses. So we have a touch and two crosses. And so that means that I would have factors of the form. Let's see, what is that number there? It looks like it's pitching at -4. So I'm going to call that one, that factor is x minus a -4, which would make it x plus 4. And since it's touching, it's going to have an even multiplicity. And I'm going to guess that it's a multiplicity of 2 because my polynomial is a degree 4. And I do have two other places that the graph is going through the x-axis. So that would mean those other two have odd multiplicities. And if they each have a multiplicity of 1, that would make sense because then I'll have this one here at 0 with a multiplicity of 1. And that last one at, what is it? In the middle of that looks like a 6. Right, so at 6, that would mean I'd have another factor at x minus +6 with a multiplicity of 1. So that's how you can factor f of x just by looking at the graph. Right, so multiplicities of 2, you just touch and bounce on the x-axis, or any even multiplicity, the same effect would happen. And any odd multiplicity, you'll see the graph go right through the x-axis. So that's a useful thing to know when you're working on how to graph a polynomial of higher degree above a 2. That might be a little tricky to look at it and figure out exactly what it looks like. You can use the end behavior and the zeros with their multiplicities to get a really good sense of the sketch of that graph right off the bat. Another thing that you'll notice here is that this is a degree 4 polynomial, which means that since it has an even degree, the end behavior will be the same, meaning that both ends will either be pointing up or both ends would be pointing down. And since the lead coefficient of x to the fourth power is a positive, that means they're both up. So the end behavior is really useful as well when we're trying to figure out what a graph should look like, or even looking at a graph and trying to figure out what the polynomial might be that matches it. Let's look at another example. This one says, find a polynomial of least possible degree having the graph shown. So once again, we can use the zeros shown here, and we can find the least possible degree. So since I see 1, 2, 3 x-intercepts that are all being crossed by the graph, I'm going to go with the least possible multiplicity, odd multiplicity for each one of those, and say that they all have a multiplicity of 1. And that's because I'm going for the least possible degree. And so I can start by writing out f of x is equal to x minus -6, which would make it x plus 6, degree 1. And then x minus 4, degree 1, and, or rather power 1, yeah, degree 1 works too, 8, x minus 8, with a multiplicity of 1. So far I've got most of my function here, but there's another part that we have to pay attention to, and that is this y-intercept. Well, what we notice here is that f of 0, whenever x is 0, the y value is 96. So I need this polynomial to satisfy that condition. And the way we'll do that is we'll put a constant here, and then we will figure out what that constant should be. And since this is whenever x is 0, I can replace all my x's with a 0. And since whenever x is 0, the y value, or the value of the function, is 96, then I can solve for a. With this being simplified, 0 plus 6 is 6, 0 minus 4 is -4, and 0 minus 8 is -8. Then simplifying this further, I have 6 times -4 is -24, and then -24 times 8, and the a is still there. So then we have a, the negative times a negative will give us a positive. Then 8 times 20 is 160, and 4 times 8 is 32. So I'm getting a times, or let me put the number in front. We have 192 times a is equal to 96. So finally I can solve for a and get a equals 96 divided by 192, which, what does that equal? Let's see. Right, so that means that the answer here to my question would be f of x is equal to 1/2 times x plus 6 times x minus 4 times x minus 8. And it says type your answer in factored form. So I did. I wrote it out in factored form here. Some of them might ask you to simplify it first, so then you would multiply all these polynomials until you get a simplified polynomial, not in factored form. The other thing I'd like you to notice is that we have x to the power of 1 here, x to the power of 2 here, x to the power of 3. Altogether, that's x to the power of 3. And remember, odd degree polynomials will have n behavior that is opposite on each side. And if the lead coefficient is positive, then it'll start low and end high, just like if you had a line with a positive slope, it would go up from left to right. So notice here that this starts low and ends high, just like I would expect in a situation like this. So let's look at another one. Graph the following polynomial equation. Okay, so now we're looking at the factored form of a polynomial, and we're supposed to choose which one of these matches the conditions represented here in the factored form of this polynomial. So being that this polynomial is already factored, it's easy for me to determine where the x-intercepts are, or the zeros of the function. So those would be at wherever x cubed equals 0, and whenever x squared minus 4 equals 0, and whenever x minus 4 equals 0. Okay, this could be written as x times x times x equals 0, which would make all three x's 0. So the zeros so far, I could say I have a 0 at x equals 0 with multiplicity of 3, which is odd. So the graph will cross the x-axis at x equals 0. Another thing I can see is that I have x squared minus 4 factors, because that's a difference of squares, to x minus 2 times x plus 2. Or if you just solved x squared equals positive 4, then it would be x equals plus or minus the square root of 4, and you would end up with plus or minus 2. And each of those have a degree of 1. So I have negative 2 and positive 2. And also this one gives me x equals 4. So also x equals 4. All of those have a multiplicity of 1, which is odd. So crosses at the x-axis. Okay. So let's go ahead and see which one of these would make the most sense. So notice another thing that I can do to narrow down the choices really fast before I even really look closely at the zeros is the end behavior. I have x to the power of 3 here, and this, and then x to the power of 2 here, and then x to the power of 1. If you add all those together, that is a degree 6 polynomial, which means with even degree, the ends should be pointing the same direction. And because the coefficient 2 is positive, that would mean that both ends should be pointed up. So I'm looking for the graph that has both ends pointed up. And it looks like the only one here that has both ends pointed up is actually option C, right? Because this has both ends pointed down, both ends pointed down. This has one down and one up. So only C could really be the answer. And I got that just by looking at the degree. So that could have saved me a lot of work if I had looked at that first. So that's a little tip that can sometimes work out well for you, although it's not always it's not always going to be that easy. But I do know that the answer has to be C. But let's look a little closer at that graph of C. If you notice, it's going through the graph, it's going through the x-axis. The graph is going through the x-axis at x equals -2. Okay, so that's check for this one. It's also going through the graph at, it looks like 0. And it's going through the x-axis at x equals 2 right there. So that's this one. And also again at x equals 1, 2, 3, 4. So that works out according to what I was expecting based on the zeros and their multiplicities, along with the end behavior. So one's done. Another one. Graph the polynomial function. Once again, we're given the factored form, and just by looking, I can see that I have a 0 at x equals 0. Okay. So I have 0 with even multiplicity, so it's going to bounce. I have here a +2 with odd multiplicity, so it's going to cross. So this one bounces. This one crosses. And then at -6, I'll also say -6 here, -6 and 0 with even, so it's going to bounce at -6 also. So, and just like before, we want to look at the end behavior, which sometimes if you look at that first, it'll narrow down your choices. I have x to the power of 2, x to the power of 1, and this 2 would be distributed in here. If I were to multiply all this out, I would end up with x squared for that factor. So that's x squared, x to the power of 2 to the power of 1 and to the power of 2 would give me a degree 5. Degree 5, which is odd So the ends point opposite. Ends opposite. Okay, so opposite direction. Well, they all have opposite, right? Every single one of these graphs point opposite directions on the ends. Also, the lead coefficient is positive, so that should mean that it's starting low. It's positive. It'll be starting low and ending high. So then that eliminates this as a choice. It also eliminates this as a choice. And I'm down to 2 possible answers. So now I can look more closely at the zeros, back up and say, what I had written down here is that -6 and 0 should bounce, and that 2 should be crossing. All right, so then this one looks right, D. D looks right. Because that does look like it might be bouncing right here. That looks like that could be -6. I see a bounce effect at x equals -6. And right here at x equals 0. And then it's kind of hard for me to write because it's so tiny. Right, so that was right there. It's bouncing at x equals 0. And then it's also crossing at what looks like could be x equal 2. So that means D is the best choice.